Today the topic is gear failure case studies. Generally, plastic gears are used in various applications such as textile industries, automobile industries, aerospace industries. Nowadays, weight reducing purpose and cost wise, most of the industries utilizing the plastic percentage increases in nowadays. The plastic gears being improved the accuracy and load capacity of its by development of plastics materials and molding process. However, many engineers are not familiar with the plastic gears could not be applied in different machines. This is because the unappropriated method for the estimating load capacity of plastic gears, therefore the standard on load capacity estimations of plastic gears would enable most engineers to estimate it adequately. Consequently, applicable field of plastic gears would become widespread. JIS B 1759 estimation of both bending strength of cylindrical plastic gears based on ISO 6336, the calculation of load capacity of spur and helical gears. In this case, the part 3, a calculation of tooth bending strength. However, the dynamic loads would be a small effect of running in could be large, so that the general influence factor of ISO 6336 are not introduced. The most mechanical properties of plastics are greatly depending on the temperatures. Therefore, the temperature factors and the temperature rise factors are introduced in JISB 1759. The present describe the outline of JISB 1759 examples, load, capacities and estimations. The main reason for the failure in plastic gears. Plastic gears fail. The gears made from the plastic materials, the materials such as mostly nylon, carbon, etc. These gears mixed with another plastic gears or steel gears are more often. With a cast iron steel gears, non-ferrous metal seldom used. When the applicable failures generally resemble those described for the metal gears. The severe plastic flow, scoring and tooth fractures indicate excessive loading, possibly associated with inadequate lubrications. Tempering colors on steel members are the sign of unsatisfactory heat dispersal by the lubricant. Wear on the metallic members of a plastics or metal gear pair usually suggest the presence of abrasive material embedded in the plastic gear teeth. This condition may derive from a dusty atmosphere or from foreign matters carried in the lubricant. When the plastic member exhibits wear, the cause is commonly attributable to a defective engaging surface on the metallic gear teeth. Surface texture should preferably not be rough than 16 μ, 0.4 μs. Many of Dyson's products implement the drivetrains typically consisting the low model plastic gears. For examples, with the brush bar assemblies in vacuum cleaner, noise from these systems can be problematic variable. This is usually due to the tolerance on parts affecting or operating the center distance, the types of gears used, and also the type motor used, which may be in fluctuation in speed. For the manufacturer, consumer goods subset impression use of the highest importance, as a pure sound quality indicates a purely designed or manufacturing the product. Given the nature of a gear noise, using classic metrics such as the sound power level, the sound pressure of gear meshing frequency may be inadequate to the captures the complexity of the noise and its effect on the perceived the sound quality. Therefore, it is proposed to apply the several acoustic metrics being loudness, sharpness, a better quality, human perfections. The acoustics simultaneous influence of a key parameters affecting a gear noise can be evaluated with the end of user perfections in mind. This study focus on the effect of change center distance for the several type of plastic gears significant. The different contact ratio which has been reported on the literatures having the influence generated noise. Increasing contact ratio shown in the reduce the SWL. It's how to use a research to drive future gear trends design, whilst also the benefit utilizing psychostatics metrics or their applications.